All right, guys, let's get started. Very good evening, very good morning. Thanks everyone for joining this session. Again, as the today's topic, the name clearly says, uh, basics of DataGuard. So the fundamental things about the DataGuard are very important to understand. Once you understand about the fundamentals, so you can easily build and you can easily, develop your own data guard strategies. So I'm going to keep it simple. Uh, and then as usual, I kept everyone on mute just to avoid any disturbance or noise. In case of anyone has any questions, queries, feel free to post it on this group here in the chat box. I'll be monitoring chat box and I can take the questions here and then. And then at the end of the question, I'll unmute everyone to ask any questions or queries. Right. The agenda for today is going to be understanding of basics of DataGuard and type of DataGuard databases and what are the different roles involved in my DataGuard database and switchover and failover concept. Right. That's a quick agenda. So in simple word, what exactly mean by DataGuard? Right, and there are many documents, many blogs you can go through, and this is one of the Oracle document you can just refer, 10G and 12C. And then starting with 19C and 21C, there are so many new feature came especially for the data guard. In simple word, what exactly data guard? Just to make it understand, you have your production database, so that's what typically you can see your primary database, and whatever the application users, whatever the end users who were connected to your primary database, they will be doing a thousands of transactions. All those transactions are regularly shipped to your standby database, right? And then you can keep the duplicate copy or the standby database in sync with your primary database at any given point of time, so that you can use this as a disaster recovery scenario. What exactly mean by disaster recovery scenario? Your primary database crashes, your primary database goes down, or your primary database entire data center is inaccessible. So immediately you can open your DR database and you can reroute all your application connections, end user connection to your standby database. So that's kind of a disaster scenario. So Oracle DataGuard ensures high availability and data protection and disaster recovery of enterprise data. So whatever the primary data, what you have it, and all your end users, applications, or the business data, business users are connecting to your primary site. In case of anything goes wrong with your primary data center, that's kind of a disaster scenario where you can open your standby database and reroute all your application to your standby database, and your business is continue to run. That's kind of a business continuity plan, right? So that's one of the enterprise solution to have your disaster recovery plan in place, right? That's a simple understanding of data guard, and many people will call it as a DG, data guard, or standby database, or secondary database, right? So you can call it as a DG, data guard, or standby database, or secondary database, or secondary duplica. Many words, but all are referring to the same, the replica of your production database, and which is in regular sync with your primary database. That's a simple understanding of data guard, right? Going next, what are the types of data guard? You can see it, right? This is a simple diagram illustration how without data guard, your primary database, and we all know there's a log writer background process. Any transactions are happening at my primary database, my log writer is going to write online read log, and this online read log, my archiver process is going to archive it, right? That's a typical production database how it works, right? And then that is without standby database. And if I can compare with my standby database, that's how typical architecture looks like. You have your primary database, and then you have this the log rater, which is a background process, whatever the online transactions, whatever the end user transactions, whatever the application transactions, whatever the users are connected, whatever the transaction they do at my database side, my log writer will do generate this online redo logs. My log writer will write from redo log buffer cache to online redo logs. And these online redo logs, my archiver process regularly backup and then move it to my archive destination, right? That's archive destination one. So that's your primary site. And if this is a primary production database, and if this production database has a standby database or the DR database, and then what happens? Either you can log writer directly can send that transaction, whatever the transactions to your standby site, or if log writer is not sending, you can whatever the archive log, you can send it to your standby site. It is left to you how you're going to configure your standby database. Regular synchronous transfer or asynchronous transfer. You can there are many ways to configure your standby database. I'm going to talk on that, but it left to you while building your standby database how you're going to transfer the data. Synchronous data transfer directly log writer can send the data to your standby site, or let archive log generate at my primary site first, and later I can push that archive log to my standby site. It is left to you. That's called asynchronous data transfer, and this is called synchronous data transfer. Once the data is transferred to your standby site, there's RFS, and that RFS, the background process will generate standby redo log, and by standby redo log, it will generate standby archive log, and these archive logs you're going to apply it on the standby database. Or if you don't want to apply the standby archive log, you want to do a real-time apply, whatever the standby redo log, directly you can apply the standby redo log to your database site. This is called real-time apply, and then this is called MRP apply, like media recovery apply. So it is left to you whether you can go with the real-time apply or the media recovery apply, or whether you can transfer that real-time sync, or you can transfer it with the async mode. Sync mode or async mode, you can define it while building your standby database. Right, that's about with the database, with the DataGuard and without DataGuard. That's a simple understanding. And then if I can go further, these are types of standby database. Whatever the standby database you're going to build, like if I say this is my prod or the primary, I'm going to build my standby database here. And this standby database, you can build it as a physical standby, logical standby, and snapshot standby, right? And any one of the mode, all are supported mode with Oracle. You can configure your standby database as a physical standby, logical standby, or the snapshot standby. And each of these standby types has its own advantages, and you can make use of that. Now, physical standby, typical standby mode, your database will be in mount mode. Your standby database will be in mount mode, and your logical standby, your database will be read or write or open mode. In the logical standby, you can open your standby database in read, write, open mode, and your snapshot standby database, you can put your database in read and write and open mode, right? Whereas your physical standby and logical standby, your primary is always in sync with your standby database. In these two conditions, physical standby and logical standby, your standby is always in sync with your primary database. If your primary sequence has 100 and standby also has the same sequence number 100, if primary has sequence number 200, your standby also has the sequence number 200. Both your physical standby and logical standby are always in sync with your primary site. Whereas snapshot standby, which will not be in sync with your primary site, right? Whatever this, your primary site has a transaction number or SCN number 100, your standby database has a SCN number 100. That's a physical standby, right? That's a physical standby. This physical standby database, you're going to convert it as a snapshot standby. The moment you convert it as a snapshot standby, whatever the transaction sync happening from the primary site to secondary site, you're going to break it. And the primary side, if you go with a transaction number or SCN number 200, it will not be applied on your standby side, because that's the significance of your snapshot standby database. Snapshot standby database indicates you are going to open your standby database in open mode, or in a read or write mode, saying that you're going to break the log shipping between primary and standby. That's a significant of your snapshot standby database. Again, the moment you convert your snapshot standby database back to physical standby database, whatever this transaction from 100 to 200, whatever the SCN number, everything will be synced back to your standby database, right? That's the importance of your snapshot standby database. What exactly that importance is, you can convert your physical standby database as a snapshot standby database, and you can convert back your snapshot standby database as a physical standby database. So the moment you convert your standby database as a snapshot standby database, it means your database in read, write, and open mode, and you can use this standby database for any reporting or any operations on the standby side, because your database is in read, write, and open mode, right? That's three types of standby database, and you can configure whichever standby database you want it while configuring your DR or the standby database. But widely, most of the industry, they're going to go with the physical standby database, and logical standby database. Very rare case, few customer will opt for that. But most of the customer in the market or in the industry, we see it all are of physical standby database. And then you can convert your physical standby as a snapshot, and later you can convert back your snapshot standby as a physical standby. So I'm going to talk on that one importance of the physical standby database in a minute, but these are the types of your standby database. Right. Once you understand clear about physical standby, again, physical standby is in a mount mode, logical standby, which will be in read and write mode, and snapshot standby database, again, which will be in read and write mode, but log shipping will not be happening from the primary to standby. Right? That's a type of your standby database. And there's the protection modes on my standby side. And again, if I draw my primary site here and my standby site is here, and then log shipping are happening here. And then this particular standby, the moment you build your standby site, again, type of standby databases as we discussed, physical standby and logical standby and snapshot standby database. Any one of these, the moment you build any one of these standby database type, and along with the standby database type, you're gonna build what kind of a protection mode you want: maximum protection, maximum availability, and maximum performance, right? These are the three types of protection mode in my standby side. While building your standby database, you're going to define what type of protection you want, right? So the first two indicates maximum protection and maximum availability. They're going to talking about data is a main point here. Data is an important aspect. Keeping the data as an important aspect. Maximum protection means they're gonna looking for maximum data protection. Maximum availability means they're looking for a maximum availability of data. And maximum performance means they're looking for the performance of the data. They're not worrying about the data, right? So these two, first one and two, there's a zero data loss. I can say both are zero data loss. And in the maximum performance, there's a minimal data loss. There's a minimal data loss here in the maximum performance. So these are the three types of protection mode. While building your standby database, you can define what type of data you want. Maximum protection mode and maximum availability mode indicates it's a synchronous data transfer. I have my prod, I have my standby database. The moment one transaction happen here, immediately the same transaction should happen on my standby side. Both my maximum protection and maximum availability called synchronous, I can say synchronous data transfer between your prod and DR. This is prod and then this is your standby. Prod and standby, between those two, the synchronous data transfer. It means whatever the transaction happens here, and immediately same transactions happens at your standby side. Both are synchronous. And when it comes to maximum performance, I have primary and then I have my standby here. What happens? The data transfer between primary to standby in the maximum performance is a delayed apply. What that mean? If the transactions are happening on primary side, let's first complete the transaction on primary side. When the transactions are complete, and then copy that data to your standby side. So that is called async mode, right? That's called async mode. In the maximum performance mode, we can say there is a async mode. And in the maximum protection, maximum availability, there's a synchronous data transfer. Whatever the transactions are happening on primary side, the same transactions are happening at the standby side, right? So that's a synchronous mode. And in the performance, that is a asynchronous mode. Since the data transfer between primary and standby is asynchronous mode, and the data whatever is generated on the primary side, it is not shipped to standby side. In that case, if the primary is crashed and whatever the new data is generated which is not transferred to your standby side, that is the minimal data loss. So that's a consideration you have to take care when you're building the standby database, right? The maximum protection or availability or performance. And in the performance, we have a minimal data loss. And in the protection and availability, there's a zero data loss because that's a synchronous data transfer. But again, these are the common interview question. What are my database protection mode? Maximum protection, maximum availability, and maximum performance. And if they ask you to brief about them, maximum protection, maximum availability, both are synchronous data transfer, and maximum performance is the asynchronous data transfer. And in the maximum performance, there is a minimal data loss. And in the both protection and availability, there is a zero data loss because that's a synchronous data transfer. Right, that's about the protection modes. Again, one of the common question in the interview, what are the protection modes of my standby database? Again, what are the types of my standby database? Your physical standby, logical standby, and the snapshot standby database. And if they say, explain about each of those types of standby database, in physical standby and logical standby, the data will be synchronous. Data will be transferred between primary and standby. Whereas in logical snapshot standby, data will not be synced from the primary and standby because your standby is open for read and write operation here. And both your physical and standby, your database will be in sync with your primary. Each and every transactions, whatever happening, it will be applied on the standby side at the same time. But whereas your snapshot standby, it cannot be applied. Right, that those are the types of standby database, and these are the protection modes of my standby database. Right. So again, as we talked about, I'm just going to draw one simple diagram. So to give more illustration between these three types of protection mode, I'm going to type 1 and 2. This is my, I can say primary, and then I'm going to say this is my standby. Right. So your primary database, and then you have your standby database. And I'm going to talk about three types of protection modes. I'm going to draw three diagrams side by side. Right. So these are three setup. First setup is your out of these three, right? I can say maximum protection mode and maximum availability and maximum performance. Right. So maximum performance and maximum availability and maximum protection. So first point, what I said, in maximum protection and maximum availability, zero data loss. Right, zero data loss. And the same thing goes to your maximum availability, zero data loss. Because the data transfer between your primary and standby is synchronous. Right. And in maximum performance, what I talked is a minimal data loss. Right. It's a minimal data loss. Why it's a minimal data loss? Because the data transfer between primary and standby is not synchronous. It's kind of asynchronous. Right? That's the only difference between your maximum performance, maximum availability, and maximum protection, maximum availability, and maximum performance. Both your protection and availability, zero data loss because the data transfer is synchronous. Data transfer is synchronous. And here data transfer is asynchronous. Right? That's where here there's a minimal data loss. What exactly synchronous means? there's a one transactions are happening here, and here also one transactions are happening, and here also one transactions are happening. There's a background process, LGWR. The background process is going to write data into your redo logs, and at the same time your log LGWR background process is going to send the data into your standby side. Same thing, LGWR, the background process, is going to write the data into your redo logs, and at the same time, same log writer is going to write the data, send the data into your standby side. That is like synchronous. Whatever the transactions are happening on the primary side, and the same time the transactions are happening at your standby side. It's a synchronous. Whereas in your maximum performance mode, it's a asynchronous. Asynchronous means your LGWR log writer is going to write the data into your redo logs first. Once the redo logs are written, and it's going to generate your archive logs here, and these archive logs are going to send into your standby side. It's not a synchronous data transfer, it's a asynchronous data transfer. Log writer is going to write the data on the primary side. It's going to generate your primary redo logs, and those primary redo logs are archived as an archive redo log, and those archive redo logs are going to send into your standby side. First, it's going to apply it on the primary side. It's going to secure your primary data first, and then it's going to send it to your standby side. That is called asynchronous data transfer, because both primary and standby are not in sync. It will be like delayed. First, data will be applied on primary, and later it will be applied on standby side here. That's a asynchronous, and that's where in that case, if the data your production is crash happened and your standby still not applied this archive log, that is going to be loss of data here. That's where it's a minimal data loss. Right, that's about the brief description about your maximum protection, maximum availability, and maximum performance. Right, and then if I can go back, let's clear this one. And then, right, if you can see, this is called asynchronous data transfer. Like your primary database, log writer is going to generate online read log. Those online read logs are archived as an archive read log by archival process, and those archive read log will be transferred to your DR side or standby side. On the standby side, there's RFS process, remote file server, which is going to receive that archive and then apply it on the standby read logs, and then it's going to generate the standby archive logs, and then you're going to apply that standby archive log into your DR site. The moment the transactions are happened here on the right, the moment the transactions are happened here, and these transactions are returned to your archive log, and then the moment it is transferring the archive log to your standby side, in that case your production database gone, and this archive log is not transferred here and it is not applied on the DR. That's your data loss. So your archive read transfer is for asynchronous, for your maximum performance mode. Right, so that's a maximum performance mode, your archive read transfer. And if I can go with the read log transfer, and there's a two methods here, async and sync. And what exactly mean by async and sync? Your primary database and your log writer is going to generate online read log, and once it generates the online read log on the primary side, and then it will send it to your standby side, and then your RFS will receive that online read log, and then it will write into your standby read log, and then it will generate your archive read log on the standby side, and you can apply your archive read log at standby side, or you can directly apply that standby read log into your database. It's called real-time apply, and this is called your MRP archived apply. And then here again, there's a delay between your production and the DR, because whatever the transactions are happened here, your log writer first returned to your primary site, and later it has sent to your standby site. There's a slight delay between your primary and standby. That's called a log transfer with a async. And if I can go to the next slide, there you can see synchronous log transfer. You can see read log transfer with a synchronous. What exactly happening here? Your primary database, whatever the transactions are happening here, your log writer is going to generate online read log at the primary side, and at the same time, your log writer with the help of LNS will going to send it to your RFS. RFS is going to generate your standby read log. If you see, observe here, whatever these transactions, end user transactions are happening, at the same time, that transactions will be applied on the primary side, and the same time it will applied on the standby read logs. So it is a synchronous here. Both primary and the standby both are in sync. And in case of production crash happens, the data whatever written on the production, it is already written on the standby side, right? And then you can use the real-time apply or the archived or the MRP apply, and your database will be in sync, right? So that's your synchronous mode. Always in the synchronous mode, we're going to use it for your maximum protection mode and maximum availability mode. And your async mode, you're going to use for maximum performance mode, right? So that's all you can define it when you were building your standby database. Great. And then I'll go next further. That's for your how we are going to do that redo log transfer or the archive log transfer. Whether you're going to use the redo log transfer or you can use the archive log transfer to your standby side. That will decide what type of protection mode you're going to go with that standby side, right? Once that is clear, and we can quickly touch base on switchover and failover, and then we can discuss question and answers after this, right? Uh, as we said, your data guard is going to be one of the business continuity plan and one of the uh, disaster recovery scenario. What exactly that mean? If I can say my primary database and my primary database right now, which is in Chicago, and my standby database, which is in Boston, and then my primary is in sync and my standby is in sync with my primary. Always transmission is happening from my Chicago to Boston, primary to standby side. And due to some disaster scenario like earthquake or like fire or whatever the reason, my entire Chicago data center is gone. Right, entire Chicago data center is gone. That's one of the um, disaster scenario. So we're not going to talk about that disaster scenario now. Uh, we can convert. That's called your switchover. We can call it as a DR drill. What exactly that DR drill? In every industry, we're going to do this DR drill once in a year. What exactly that DR drill? In case of any disaster happens, we should be able to continue our business. How we are going to test that scenario. So that's called switchover. So what we're going to do, we're going to convert my Boston with my standby database. I'll make it as a primary, and Chicago, which is my primary, and I'll make it as a standby. And I'm going to start the log shipping from the Boston to Chicago in the reverse direction. I'm going to convert primary as a standby and standby as a primary. And then the log shipping is going to start happening with the reverse direction from Boston to Chicago. So that's called switchover. We are going to do once in a year at least in order to make sure that in case of any worst scenario, disaster scenario, we should be able to continue our business, right? So in every IT industry, DR drill is going to must activity. We're going to do once in a year, right? This is your switchover, planned switchover activity. And then unplanned, that is disaster scenario, disaster recovery, right? So this is what your failure we can call it as. We can call it as a failure. So chore is a planned activity. We do it in once in a year. We can call it as a DRL activity. What is failure? Failure is a actual disaster scenario happened. Actual disaster scenario happened like before failure. Your primary is in Chicago and standby is in Boston. And in the Chicago data center, entire database is gone. Entire data center is crashed because of the earthquake or fire or whatever reason. And in that case, we have to quickly act and we have to quickly back to business. How we're going to do that one? My primary is gone, and whatever the standby database which is in Boston, I'm gonna make it as a primary, and I'm gonna make that as a primary database, and I'm gonna whatever the applications are connected to my Chicago primary database, I'll ask them to connect to my DR database. The DR database is now become primary here. All the applications app is going to connect to my standby side here, right? And then users, apps and users, everything will gonna connect to my new primary database here. That's called failover. That's kind of a business continuity plan in case of primary goes down and you're gonna bring your primary standby database as a primary database and your business is continue to run here. That's called your failover. So this one we will not do it in an industry, because that indicates failover. It means in case of actual disaster happens, we're going to do this failover. Otherwise, we're going to do that switchover activity once in a year. Right? This is your switchover activity here. Switchover activity, we can call it as a DataGuard switchover. That we do it, we call it as a DR drill, and we're going to do it once in a year, or sometimes they will do twice in a year, right? There's a one question here. I have one basic questions. Tejas is asking. I have production standalone and another fresh server with nothing installed on it. So my action plan will be create a grid, install DB software, and start duplicating. Create DB and before duplicating. Okay, I'll talk on that. I'll talk on that. Okay. Right. So that is your failover. That's all what I planned here. I'm gonna cover few more basics here. So I have my primary. How we can configure your standby? There's a common questions, right? Like I have my ASM and I have my prod DB. And then I can configure here ASM same storage, and then I'm configure my DR here. That's possible. Standalone to standalone, ASM to ASM. That's possible. And I'm gonna set up one more scenario. Without ASM, I have my prod, and then I can configure my DR. Again, standalone to standalone, my prod, which is running under, I can say FS file system, not on the ASM. Again, you can configure your DR in the file system, standalone to standalone. That's also possible. This is your option 1, and this is your option 2. And the third option and the fourth option, you have ASM, and then you have prod database. Prod database is running on ASM, and you can configure your DR database, which is on file system. You no need to have ASM. Standalone to standalone, production is running on ASM. You can run your DR on the file system. That's also possible. And your prod database, which is running and which is on file system. And you can have your DR database and which is running on your ASM. That's your option 4. ASM to ASM, file system to file system, or ASM to file system, or file system to ASM. All 4 options are supported here. And there's a few more options. I have my 2-node rack here. Right, let's see. I can take it off once again. Give me a second. Right, I can take one more options here. I have my primary database, which is a rack, right? And then obviously rack is going to run with your ASM. And then this is your ASM. You have 2-node rack, and then your database will be running here. And then obviously this is your prod, and you can have the same setup, 2-node rack, and you can have the same 2-node rack of your DR database. And there won't be any restriction, like 2-node to 2-node. And then this is your prod, and then this is your DR. That's one way. And the other scenario, like again, I can take this as an example. You have 2-node prod database here, and then you can go ahead and then have a single node standalone database, right? And then that too in ASM, you have ASM, and then you have your DR database over here, right? And then this is your DR. Like, it's a 2-node to 1-node, right? So you have 2-node rack, which is running on ASM, and you can have a single node DR, again, which is running on ASM. And there's one more scenario, like you have 2-node rack, which is running on ASM, and you can run your DR on a single node. I can say this is my DR, and which is running under file system, right? So all these combinations, there is no restriction at all, right? So whatever type of standby database you want to build, whatever the mismatch configuration, you can go ahead and configure. There's no restriction at all from Oracle side. You can go with the standalone to standalone, or rack to rack, or rack to standalone, or standalone to rack, or file system to ASM, or ASM to file system. All those are supported configuration for your DR build. But as per the MA architecture, right? As per the Oracle standard MA architecture, MA architecture indicates maximum availability architecture, MAA architecture, maximum availability architecture. Always suggest go with the rack production database and configure the rack DR database, so that you have a high availability, maximum protection, and data protection. Everything will be covered over here, right? This is the best practice. Multiple node rack database production and rack database standby database, right? I'll just uh, unmute everyone, and if anyone has any questions, we can take it. Right. Kalim is asking, can we show some basic? I'm not going to show any demo here because I already taken a lot of live demonstration in my channel. Building from the scratch, building rack to rack standby, building standalone to standalone standby. Probably you can refer those. Yep.
Malik, which one would you prefer in pre-production mode? Which one, while configuring standby database, which one you prefer? Means maximum availability, maximum production, or maximum performance? Which one is the best?
It is left to you how critical your database is, right? As I said, if you go with the maximum performance mode, and in case of disaster scenario, there is a minimal data loss, right?
Okay.
Because if there's a data is not transferred from the primary to standby, and obviously there's a data loss, and your production database crashed, and then how you're going to connect, how you're going to recover your database on the standby side. And if you're worrying about data is the highest priority, always go with the maximum protection or maximum availability. In most of the banking sectors, whatever the finance sector, they always go with the maximum protection mode. That's the highest level of data protection, because you'll never gonna lose a single bit of data here, right?
Yes. Yeah.
Okay. In banking and in finance sector, whatever like insurance sector where I worked, I saw it will be always maximum protection. And if there's a less data criticality and all those scenario, you can always go with the maximum performance if you're not worrying about the data.
Okay.
Thank you, Malik. How do we perform log shipping?
Log shipping, we're not doing it. Your Oracle will take care of that, right? What's the use of standby, right? It's automated. Everything Oracle has to my job is to set up my standby database. Once standby is built, Oracle will sync that. Oracle will ship that logs, and it will take care of that. And there's other scenario. In certain scenario, my DR will go out of sync, and then how I can make it my DR in sync with prod by taking incremental backup or restoring using a service based. Again, there is all in my previous live webinars. I covered this live syncing my standby database and all those topics. You can just refer them. Yeah.
Malik, once again, can you please brief this one? Standby and logical and physical standby database. Just brief.
Right. I can do that one. Okay, so these are your types of standby database. Let's go here. I can take one more slide. My primary and my standby. This is my prod, and then this is my DR. I'll take 3 example here. 1 and 2. Okay, these 3 types. One is your physical standby, and the other one is your logical standby, and the other one is your snapshot standby. So physical standby, and then this is your prod, and this is your DR. Right, your prod is always, we know this will be in read and write. It will be like always in open mode. Your prod will be always in open mode, read write mode. All the transactions are happening here. When it comes to your physical standby, your physical standby will be in mounted mode, or you can say mount mode. And always there will be like, and this will be mount mode, and logical standby will be read and write and open mode. And your snapshot standby read and write and open mode, right? This is mount mode, and these are like read write open mode, read write open mode. And if I say read write open mode and read write open mode, what's the difference between these two? Right? Your physical standby and logical standby, always data will be in sync. It means whatever the transactions are happening on your primary side, all those transactions will be shipped to your standby, and then it'll applied on the standby. Whether it's applied on synchronous, asynchronous, or delayed applied, doesn't matter. It will be keep on applying on your standby side. But when it comes to snapshot standby, sorry for that. When it comes to snapshot standby, data will be transferred but not applied on the standby side here. So what happens in snapshot standby? You're going to break that log shipping apply here, and you're going to open your standby database in read write open mode. And whatever this mount mode database, you're going to convert read write open. Whatever this physical snapshot, physical standby database, you're going to convert it as a snapshot standby database. The moment you open your data database as a snapshot standby database, it means it's going to stop that log shipping. Whatever the transactions are happening here, it's going to stop that log shipping applying on the standby side. Whatever that log shipping, like SCA number 100, it applied on 100. And after that, whatever the transactions are happening, all those transactions are not applied on your standby side, because you broke that chain and you opened your database in read write open mode, so that you can give this for your end user for reporting, or from applications, or from some testing, you can give it to them. Once that testing is over, once they're done with the reporting and testing is over, and later you can start applying your standby. It means you can convert your snapshot standby database back to your physical standby database, so that whatever the missing, whatever the sequence transactions that happened, it will try to apply on your DR side, and DR will become sync with your primary side. That's a use case of a snapshot standby database. It means whatever the physical standby database, you can convert it as a snapshot standby database. That's going to break the chain, and you can open your database in read write mode, and you can give it to any end user business. They can run any reporting query and testing they can do. Once the testing is done, you can again start that log shipping apply, and it's going to convert it back to physical standby. That's a use case of your snapshot standby.
Okay,
Right.
but in physical standby, always DR it will be in the mount state only, right?
Right. It will be in mount state always.
Okay, thank you, Malik.
Hello, sir.
And logical, what will happen, Malik? Can I come again, please?
Logical, it will be a different story altogether. What exactly logical standby happens? Your primary will be in read write, and you are going to sync your primary database and DR database. Your DR and primary will be always in sync. Like your transactions will be happening here. Whatever the transactions are going to happen, all the tables, whatever the primary side, you will be in sync with your DR side. And at the same time, you are going to open your database in read and write mode, and your database will be read and write mode. And in the standby, in the primary side, you have 100 tables. All those 100 tables will be in sync with your DR side. Your primary and DR will be in sync. And at the same time, you are going to open your DR database in read write open mode, which will allow you to create some tables. Like I'm going to create 101 table, 102 table, some extra table I can create it, and I can use these tables. I can read, write, I can do any modification I want it on these tables. That's the extra feasibility it will gonna comes with your logical standby. Right. So that's a different way of configuring your logical standby. So that's a very rare, many customer will not go with this kind of configuration.
So
Most
we
of
can't
them,
go back like a snapshot standby, no? Like that is a last SCA number 100, it was stopped, right? Synchronization. So here we will not have any option to go back, no? Once we open the DB.
no, this is not, this logical standby is the different settings, right? It is not like open. Your DR itself default comes with open mode. Right? If I can clear everything, like this is your setting. The moment you create your DR as a logical standby, your DR will comes default with a read write open mode. It's not like a mount mode. And your whatever the transactions will be happening here. Your SCN number is 100 and your SCN number will be 100. And your SCN number will get changed to 200 and your DR will be again sync. Your DR will be always in sync with your primary side. And at the same time, your DR will be opened in read write mode so that you can create any table you want it on the DR side, table 1, table 2, table 3.
Okay, so same will be reflected in prod also again.
No, it's a one-way replication, right? Prod to
Yes,
DR
yes.
replication, not
So
from the
standby
DR.
only will be different and then prod will be different. No? Okay.
No, your whatever the prod 100 tables you have it, all those 100 tables are synced here. But you're going to extract, you're going to create some table on the DR side because your DR database is in read write mode. That's the extra table you're going to create it on the DR side. That's the use of logical
I
standby.
understood, but when we switch over to prod now, so this will not be in sync now.
Yeah, it will not
I
be in
don't know
sync. Yes.
possible to switch over or not. But,
Switchover is not possible here.
uh,
In logical standby, the switchover is not possible. You cannot do a prod to DR and DR to prod. You cannot, switchover is not possible in the logical standby.
Okay.
Only in the
Only in
physical
physical
standby,
standby.
you can do switchover and failover.
Yeah.
But
Just to understand, I asked that question.
yeah,
like,
logic again,
yeah.
it makes sense, right? The moment you create extra tables and the switchover is not possible here.
Correct.
That's why many customers will not go with this logical standby because your disaster recovery is useless here. The DR is meant for your disaster recovery, right? So if you convert it logical standby, and that's a mess. You cannot anything goes wrong with your prod, and you cannot do a failover or you cannot do a switchover.
Okay. And coming to this maximum protection and maximum availability you mentioned, right? Both are, I mean, scenario-wise zero data loss, and both are in the synchronous mode.
Synchronous mode, yes.
Okay, I understood. But what is the difference between these two again?
Again, difference between those two is one important factor is your right. So your maximum protection mode, maximum availability mode, both are zero data loss. I have primary, I have standby. And primary, some transactions happened and it's going to send it to my DR, and your DR has to send the acknowledgement. Okay, whatever the transaction you have sent it, I return to my database here. Your DR has to send acknowledgement back to your production side. That's called maximum protection. If this DR did not send the acknowledgement back, and your production database will be hanged. Your production database will not work. Whereas in maximum availability, same thing goes. Your production database, your DR database, and some transactions are happened, and this transaction information will be sent to your DR site, and your DR has to send the acknowledgement. And while sending acknowledgement, your DR has some network issue, and your DR did not send the acknowledgement. And as per the settings, default it's going to use it, wait for 60 seconds. The moment it wait for 60 seconds, and within that 60 seconds, if this DR did not send a response to your production, and your availability will gonna convert it as a performance mode by default, and your production database is gonna continue to work. So that's the indication of your availability and protection mode. Both are synchronous, but in case of protection mode, your primary will at any cost wait until DR send the acknowledgement. And if the DR did not send the acknowledgement, your primary database will halt. Your primary database will be hung. Your primary database will go down. And in case of availability, your both are in sync, and your DR has to send acknowledgement. And if your DR database did not send acknowledgement, there's a default 60 second it will wait. And within that 60 second, your DR database did not send acknowledgement, availability become performance mode. Default is going to convert it to performance mode. And in performance mode, we know that's asynchronous. Just send the data. Don't worry
Is
about
a
it.
gap process, right? Malik?
There's something called gap.
Got it.
There's a net timeout.
Okay.
Okay, acknowledgement plays the major role here.
Right.
Okay, thank you.
Thank you, Malik.
Malik, in first part, maximum protection. So is there is any time limit, like, in maximum availability that it will wait for
No
60
time
seconds?
limit. The moment your DR did not send acknowledgement, your production will crash. Your production will go hung.
Got it. Thank you, Malik.
Hello, sir.
Yep.
In the beginning, I had asked a question regarding a scenario. Suppose I have a PR and I need to create a DR, which is a fresh server. So what will be my action plan? Basically, like I have a standalone PR. So I just need to install Grid, need to download the DB software. Do I need to create DB or just
No,
directly do?
you don't need to create, right? You're not going to create. You're going to use the production backup. And again, I already cleared in my previous session. I did a standalone from the scratch how we're going to build rack to rack database, how you can build it. I already covered it in our previous live webinars. Probably you can watch them. You have to take a
Okay.
primary backup, or you can use a Arman active database duplicate.
Yeah, Arman active
And-
database duplicate. So basically, just I need first the Grid home installed on my DR and my DB software to be installed, and then I can directly start with duplication, right?
Yeah, duplication, active database duplication, or active database duplication from the backup. Any one method you can choose.
Okay. So basically, the all the data and everything stuff will be get transferred from PR to DR, right?
Right.
Okay. Yeah, that's the only question. Thank you for the session. It was really informative, sir. Thank you.
All right. Anyone has any last question before we wind up?
Malik sir, why the DR is in mount stage in physical standby?
That's a default configuration. Your physical standby always in a mount mode. That's your standby database.
Can we bring it in open mode, or at Oracle Advantage will bring it if in case disaster happens?
There is no way you can bring it in open mode. Mount mode is a maximum mode for that.
Yeah, Malik sir, can we perform DML operation on logical standby on the existing table, not the extra table?
There is a way you can do it, but you have to configure that on in existing table also you can do it, and some extra table also you can do the DML operations. You have to configure that.
Okay.
Yep. All right. Any more last questions?
Yeah, Malik, I just posted one message on chat. Whether this active DataGuard and DataGuard are same, both?
Again, that's one interesting questions. Where is that one? Do I have that one? Okay, here. We talked about a physical standby, and this physical standby which will be in mount mode, and then there's a separate license. There's a separate license you have to purchase from Oracle. That's called ADG, Active Data Guard license. ADG, that's an Active Data Guard license that you have to purchase. The moment you purchase this Active Data Guard license, and then whatever this mount mode database, you can open read only with apply. You can open your database with the read only and apply mode. You're going to open your database in read only mode, and at the same times you're going to apply the transactions. That's called your Active Data Guard. That's a separate license you have to purchase from Oracle, and you can open your standby database instead of mount mode. You can open in read only with apply mode. That's your Active Data Guard license.
And Malik, that DataGuard broker and Active DataGuard is same.
Now, Active Data Guard is a separate license. You're going to purchase it from the Oracle side. DG broker, we can call it a DataGuard broker, is a separate software, or like the way the software you can install it on the same server or on the different server, where you can monitor your sync between primary and standby, and whatever this switchover failure, whatever we talked, right? That you have to run multiple command, like 10 to 20 command you have to run it, and you can do a switchover and failover. But when you're using a DG guard, data guard broker, just a single command which will convert primary as a standby and standby as a primary. That's a separate software. You have to install it and configure your standby databases, so that with a simple commands you can do switchover and failover.
Okay. Super. Okay. Thank you, Malik.
All right, guys. Let's stop it for today, and we'll see you in next session. Thank you all.
Yeah.
Thanks
a
for the
lot.
session.
Super,
Thank you, Malik.
super.
Thank
Thank
you.
you a lot, Malik.
Thank you.
Thank you.